Hello students, good afternoon and namaskar all. Yeah, good evening Bunny M. Is audio video is clear? Please comment about it. Good evening Ravi Shankar. Clear? Thank you, thank you. So today we are in the topic transport layer and that is the lecture number 3. So in the previous 2 lectures we have seen that in the previous lecture we have talked about multiplexing and demultiplexing at the transport layer. Good evening Nishant Kumar. So multiplexing and demultiplexing in the transport layer. Sorry. Demultiplexing we will talk little bit later in more detail. So in the previous class we have talked about UDP header format, and UDP is a very lightweight protocol. No any detailed question asking in the exam. So theory question is only, but TCP is a very important protocol for us. So we have seen the TCP header format. Yesterday we have seen the TCP header format, and in the TCP header we have talked about sequence number and acknowledgement number. Sequence number and acknowledgement number. So here we will continue the same quick recap of sequence number and acknowledgement number, and then there is a one homework question. We will continue with that question, and then there is a maximum segment lifetime, that is MSL. This is also known as wrap around time, and this is also known as wrap around time. So what is wrap around time? What is MSL? What is the maximum segment lifetime? There is a question on GATE. There is a question in GATE on this topic. So we will see this variety of questions, and after that we will move to the very important part in the TCP, that is the TCP connections. What I told in UDP, no need to establish a connection, but in case of TCP we have to establish logical connection. So TCP connection establishment, and then TCP connection release. So we are going to start with the homework question. So this is introduction slide, this one. So what I told, in TCP sequence number field, the second word is a sequence number. In the header, first word is containing the port number, source port number and destination port number. In header, the first word is source port number and destination port number, and the second word is sequence number. Good evening Mihir Vijay. So second word is sequence number, and then we are talking about sequence number. We have already seen. So TCP is a byte stream protocol. Basically it's a stream oriented protocol. Every byte of the message, so every byte of the message, whatever the message is received by the application process. So every bytes is identified with unique sequence number, or every byte is assigned unique sequence number. Although sequence number is 32-bit long, although sequence number is 32-bit long, so the sequence number is going to repeat the same number 0 to the power 32 minus 1, and then 0 to the power 32 minus 1, it is going to repeat. But if we are considering it, the number is going to repeat it till that previous number is out of expiry. So no any issue. So what I am telling, that every byte is identified with unique sequence number. So there is a one question in GATE, that unique sequence number is assigned to each byte. Unique sequence number is assigned to each byte, and every byte in service data unit is identified. We can identify any byte by using that number. So if I am telling the byte number 7432, so accordingly we will count, and then we will reach up to that byte and find it out, and that byte belongs to that byte will be in one of the TCP segment, so we can identify accordingly. Now question comes here. Now the question comes here, in the TCP header format. In the TCP header format, there is a second word, that is a sequence number, and that is a 32-bit. So in header we have to mention one sequence number only. In header we have to mention one sequence number only, and remember, sequence number is not assigned to segment, sequence number is assigned to byte. So in header there is a sequence number field. In header there is a sequence number field. What to write in that sequence number field? What to write in that sequence number field? So it is telling that the TCP segment is carrying the payload. The TCP segment is carrying the payload. So in the payload there is a first byte. In the payload there is a first byte. The first byte sequence number is going to write in the header sequence number field. So TCP header is going to contain a sequence number, which is basically a sequence number of first byte of the payload, because it's difficult or is unable to write all the sequence number. So we are just writing the leader byte sequence number. Leader byte means leading byte sequence number. So leading byte sequence number is written in the TCP segment header. TCP header. So it is written here, the sequence number in TCP segment is the first byte sequence number of payload. So the first byte of the payload, and whose sequence number is, so first byte sequence number of the payload. So it is written in the TCP segment header. Accordingly, second segment sequence number, accordingly third segment sequence number. So sequence number we are not assigning to segment, sequence number we are assigning to bytes, and accordingly first byte sequence number is written in the header. It's a leading byte sequence number. We have already seen this part. If any doubt, then ask. Good afternoon, Shubham. So if any doubt, then ask. Now what is acknowledgement number? Sorry, what is acknowledgement number? So in case of acknowledgement number, whenever receiver receives a segment, then what receiver will do? Receiver have to acknowledge it. Why? Because in case of UDP, no any sequence number, no any acknowledgement. In case of UDP, no sequence number. We have seen in UDP header format, no any place for sequence number. UDP is not dealing with sequence number, and UDP there is a no any acknowledgement, no any provision of acknowledgement. Then what? In case of TCP is going to maintain sequence number of bytes. Accordingly, it will mention the sequence number in the header, and then receiver is always sending the acknowledgement of receive segment. Receiver is always sending the acknowledgement of receive segment. Whenever I am talking about acknowledgement, by default positive acknowledgement. So whenever transmitter is sending one segment, receiver receive that segment, immediately receiver send acknowledgement. Immediately receiver send acknowledgement. So what happened here? Receiver is sending acknowledgement. So what receiver is sending as acknowledgement? In data link layer, we have studied one topic, flow control, in which I have discussed two cases. When frame with sequence number 0 is transmitted and receiver receives that frame, receiver is sending what acknowledgement? Acknowledgement 0 or acknowledgement 1. That time I was telling that both are correct. It's depend on implementation. It's depend on implementation or assumption. If receiver is sending acknowledgement 0 for the receive frame with sequence number 0, 0 for 0. It means receiver is telling that 0, the frame with sequence number 0 received successfully, no any problem. There is another case, what? In which receiver is telling that in case of frame with sequence number 0 is received and receiver is telling that acknowledgement 1. What is the meaning of acknowledgement 1? Acknowledgement 1 means receiver is telling that I am looking for frame with sequence number 1. I am looking for frame with sequence number 1. So both the concept is there. Whatever you are receiving, that you are acknowledging. Other is telling that whatever you are receiving, do not acknowledge that. Whatever you are expecting, whatever you are looking for, tell that number only. So in case of 0 to 0, in case 0, one case is that 0 for 0 and one case is 1 for 0. So 0 for 0 means 0 received. 1 for 0 means I am looking for 1. So what I told at that time? What I told that time? The TCP is going to use second part. TCP is going to use case 2. Case 2 means in TCP we always tell, in TCP receiver always tell acknowledgement number of expected segment. In TCP receiver always tell acknowledgement number of expected segment. It never tell acknowledgement number of received segment. It never tell acknowledgement number for receive segment. It is telling acknowledgement number for expected byte. So basically what acknowledgement is saying, this in TCP acknowledgements are cumulative. So TCP acknowledgements are always piggybacked. What is the meaning of piggybacked? The same segment header will contain acknowledgement field number, and if we have data, then do not send data and acknowledgement separately. We can mix in one packet. We can mix in one segment. Payload part contain data. That data have sequence number. First byte sequence number is written in sequence number. If receiver is having something to acknowledge, so it will send acknowledgement number along with that data. So it's a piggybacking concept. So so basically data and acknowledgement are part of same packet. So it's a piggybacking, and TCP uses cumulative acknowledgement. So whatever the byte number indicated by the receiver, whatever the byte number informed by the receiver, it is telling that I am looking for that byte number. I am looking for the segment whose sequence number is this. So receiver always telling that I am looking for a segment whose sequence number is this. It means before that segment is demanded by the receiver, expected by the receiver, looking by the receiver, before that everything is clear. It's a meaning of cumulative acknowledgement. So we have seen yesterday example that so receiver is always putting acknowledgement number what? Receiver is always putting acknowledgement number that whatever the segment received by the receiver, that segment first byte sequence number is written in the header. That segment first byte sequence number is written in the header. Accordingly, can we able to evaluate last byte sequence number of that payload? Accordingly, can we able to evaluate last byte sequence number of the payload? Yes, and that last byte is not indicated by the receiver. Receiver always indicating the next byte. I am looking for that byte number. I am looking for the segment whose sequence number is this. So whatever the last byte sequence number, we have to add 1, and accordingly it will indicate that I am looking for that byte number. I am expecting for that byte number. So remember, in TCP acknowledgement number is always the expected segment. Acknowledgement number is always pointing the expected segment sequence number. So there is only one case in case of TCP, but in case of data link layer we have two implementation, case 1 and case 2. But in case of transport layer, in case of TCP, no any case 1, only case 2. No any case 1, only case 2. We receiver always pointing expected segment. Receiver always telling the number whose segment is expected, next expected sequence number. So here it is telling that whenever any TCP is receiving a segment from opposite end, so TCP is a point to point full duplex protocol. So one TCP socket, one TCP socket. So both the sockets are doing communication. So one TCP is sending segment to other TCP. So other TCP is always going to check whether acknowledgement flag is on or off. If acknowledgement flag is off, means the opposite TCP is not sending any acknowledgement. The acknowledgement field is containing the garbage value. But if the TCP is receiving one segment from the opposite side TCP, and it's going to check, and the acknowledgement flag is on. It means the opposite side TCP is sending acknowledgement along with their data. So the header contain acknowledgement field, and that acknowledgement number is not garbage value. It is acknowledgement number sent by the opposite end TCP, and the opposite end TCP is sending acknowledgement of mine data which I sent few times back. So here in this way, it's a acknowledgement number is calculated, and this equation is very important. And this equation is very important. Sorry, this condition to determine. So acknowledgement flag is always playing very huge and crucial role to determine whether the segment carries acknowledgement or not carries. So acknowledgement flag will indicate that yes, it carry acknowledgement, it does not carry acknowledgement, like that. So here the question previous year 2007, there is one homework question. In 2007 IIT Kanpur questions is there, and this is a homework question, and hope you have solved. I hope you have solved, and A, B, C, D, 4 options are there. The correct answer MCQ, multiple choice question, 30 seconds. So here in this question, the question is telling consider a TCP connection in state where there are no outstanding acknowledgement. What is the meaning of outstanding acknowledgement? The outstanding acknowledgement means the receiver is sending acknowledgement of those segment which were already acknowledges. Which were already acknowledges means receiver is sending duplicate acknowledgement. Receiver is sending duplicate acknowledgement, assuming that previous acknowledgement lost. Assuming that previous acknowledgement is lost, but previous acknowledgement is not actually lost. So previous acknowledgement already arrived, and it acknowledges a segment. That segment is already removed from the sending window, and the same acknowledgement arrive again, and it is acknowledging the segment which already removed by the sender sending window. So if any acknowledgement is if an acknowledgement of a segment whose already acknowledges which were exist in the sending window, so that was a outstanding acknowledgement. So in case of outstanding acknowledgement, sender do nothing, ignore it, avoid it, and it is telling that no any outstanding acknowledgement. Okay, the sender sends two segment back to back. The sender sends two segment back to back. As per the question, sender is sending two segments back to back. Okay, and this is one segment, and this is one segment. Back to back two segments are transmitted by the sender. Let's suppose in case of in case of segment, header part is there, and in this question TCP connection is there. So with the TCP connection, TCP protocol is used, TCP segment. So TCP header in both the segment. Okay, and there is a payload field. There is a payload field in both the segment, and the question is telling the sender send two segment back to back, means whatever the data is carrying in this payload, and the data carrying in this payload, in this packet payload, it is just after this data. So here in the message, here we can say the application process generating a messages in which this data is generated by application process, and this data just following this data. So this payload 1 and this payload 2. So here I am writing for your understanding, payload 1 and payload 2 are continuous, means just after this byte, the next byte from the sending window is this byte. Then the question is telling the sequence number of the first and second segments are 230 and 290 respectively. As per the question, the sequence number in the header field is 230 and 290. Two 30 and 290 are the sequence number respectively. What we have studied? The sequence number field contain the sequence number of first byte of the payload. So basically, the first byte of the payload, have sequence number 230, which is written in the header part, leading byte sequence number, and the sequence number 290 means the first byte sequence number is 290. First byte sequence number is 290. So 230 and 290 is the first byte sequence number of their respective packets. Then the first segment was lost. Okay, so why the sender have transmitted two segment, transmitter have transmitted two segments, sender have sent two segment, this and this. Unfortunately, this segment is forwarded by the network layer and gone in one particular path, and the path is having condition. Due to that condition, this packet gone lost. Assume that, and this segment is lost, but this segment is forwarded by the data link layer from some other path that might possible that segment reaches. So as per the question, this segment is not reaches at the receiver end, but this segment is reaches at the receiving end. Okay, this lost, this reaches. So as per the question, first segment was lost and the second segment was received correctly by the receiver. First segment was lost and the second segment was received correctly by the receiver. And let X be the amount of data carried in the first segment. So it is telling that the this payload 1, size of payload 1. So X is the size, it is telling that X is the size amount of data carried in the first segment in bytes. So tell me, if this sequence number is 290, so definitely this byte sequence number is 289. Then definitely this byte sequence number is 289. Why? As per the question, these two segments are back to back. As per the question, these two segments are transmitted back to back. So this segment is carrying the data in the payload part, which is actually following this data. So it is a continuous data. So whatever the data present in payload 1 and whatever the data present in payload 2, the payload 2 data is just continuous after that. So here, if the previous, so here, can we able to find out the size of payload 1? Yes, the size of payload 1, that is X. So it is telling that the size of, it is asking that let X be the amount of data carried in the first segment. So size of payload 1, and that value is X is equal to what? The next byte, next segment sequence number is 290. Next segment sequence number is 290 and the previous segment sequence number is 230. If we subtract these two, then you will get the answer in bytes. That is the size of payload 1 in bytes. So the answer of this question, and the value of X is 60 byte. And the value of X is 60 byte. So basically here 60 bytes is present in the payload 1. That's why this byte number is 230, this byte number is 289 and the next byte number is 290. So accordingly, this sequence number is 230, this sequence number is 290. So the size of payload 1, that is X, the value of X is 60. Check, the value of X is 60. In this question what it is asking, and Y be the acknowledgement number sent by the receiver. Y be the acknowledgement number sent by the receiver. The value of x and y in that order. The value of x and y in that order. So the value of x is 60. So value of x is 60. B cannot be our answer. 60, 60, 60. Our answer can be either A or B, sorry, C or D, A, C, D. B rejected. B rejected. Now question comes in the picture. Now question comes in the picture. This segment is lost, not received by the receiver, and receiver receives second segment. Receiver receives second segment. Let's suppose if receiver receives first segment, then receiver send acknowledgement number 290, and when receiver receives second segment, then receiver will send acknowledgement number 290 plus size of payload 2. 290 plus size of payload 2. The size of payload 2 can be anything. It can be either 60 byte, it can be more than 60 byte, it can be less than 60 byte. Do not know. But remember, when this segment is missing, then receiver is not going to acknowledge this segment. Receiver is not going to acknowledge this segment. Why? If this segment is going to acknowledge, means all the byte till here, including these, are acknowledged by the receiver due to cumulative acknowledgement. So as per the cumulative acknowledgement, receiver is not going to acknowledge the second segment because the previous segment is missing, and second segment is going to store in the receiver buffer. Second segment is going to store in the receiving buffer, but not acknowledges. So what happened? What receiver will do? Receiver will find out that receiver is waiting for a segment whose sequence number is 230. Receiver is waiting for a segment whose sequence number is 230, and in spite of 230, receiver directly receive what? Receiver directly receive 290, and when 290 is the segment whose sequence number is 290 received by the receiver, receiver immediately find out that I am waiting for 230 and I am receiving 290. I am waiting for 230 and 230 is not coming, directly 290 is coming. It means there are some bytes missing. 230 to 289 bytes missing, and I am receiving the byte number 290. So what receiver will do? Receiver will send acknowledgement which is telling that I am waiting for the byte number 230. I am waiting for the segment whose sequence number is 230. So here in this case what happened? It is telling that the size of payload 1, that is x, we can easily evaluate by subtracting these two sequence number. Okay, size of payload 1, amount of data carried in the first payload, that's okay, first packet, first segment, okay. But the second thing, it is asking that in spite of first segment is lost. In spite of first segment, directly second segment reaches. Immediately receiver got to know I was expecting for 230 and I am receiving 290. There is a something missing. And what is missing? Obviously some segments are missing, 1 or 2, I do not know, but I have to tell to the sender I am waiting for 290. Sorry, I am waiting for 230. I am looking for 230 and 230 is not received yet. So it is telling that the y be the acknowledgement number. Y be the acknowledgement number sent by the receiver. So here the acknowledgement number, that is y, sent by the receiver. So here this segment is missing, this segment has arrived. Receiver will store this segment in the buffer but not acknowledges. So receiver will send I am looking for segment, sorry, I am looking for segment I am waiting for segment whose sequence number field contain value 230. Because the byte number 230 I am expecting, and directly you are sending byte number 290, that is a future byte. I am waiting for the byte number 230. I am waiting for the segment in which sequence number is 230. So when this segment is arrived, in spite of this, receiver will send this acknowledgement number. First send 230, then it is become worthy for me, then it's become useful for me. Otherwise it's a future segment I am keeping in the buffer but not acknowledging because of cumulative acknowledgement, because of combined acknowledgement. So the value of y, is 230. So 230 means I am looking for the byte number 230. So this is 290, no. If receiver is telling that 290, it means it is telling that I am looking for 290 and till byte number 289 I have received everything. Is it true? No. This is missing, this is received. So no acknowledgement number 290. Second, 60 and 231. 230 means I am looking for the byte number 231. I am looking for the byte number 231 and till byte 230 everything is received. No, till byte 229 everything is received and receiver is looking for byte number 230. 230 is not received. So this is wrong. 60 and 230, the correct answer of this question is D. Correct answer of this question is D. So no one participated in poll. Is there any doubt? Poll is not showing in your device. Poll is not showing in your device. Is there any issue? Or you have not solved this question, or what is the problem? Poll is not showing. Okay. We have to update. Poll didn't work. Answer was correct. Okay. Bunny M is saying poll didn't work. Okay. So there is a update for technical team. Poll is not working. We will check for further question also. So is there any doubt with this question? Is there any doubt with this question? Any doubt, then ask. No any doubt, then we will move to next part. So here we can easily evaluate the size of payload 1, but we are unable to determine the size of payload 2. Why? Because we do not know what is the size of payload 2. Payload 2 can carry how many bytes? It's totally determined by the next segment sequence number. If next segment sequence number is something, then accordingly we will subtract these two value and then we will got the payload 2 size. So then we are moving to the next. What happened? Why this is not working? Okay, so we are moving to the next part of the question. This is a maximum segment lifetime. So what is the maximum segment lifetime? We can understand this part. We can understand this part. Why it is creating a problem here? So and the maximum segment lifetime. Let's suppose there is a process 1. There is a process 1 and process 1 is having one socket, and through this socket it is giving the data to TCP. So basically it's a TCP socket. Then and there is a buffer, sending buffer, and there is a buffer, that is sending buffer. So here it is sending buffer with respect to that socket. So what I am telling, in case of TCP or in case of UDP, Basically in case of TCP socket, every socket is having two buffer, sending buffer and receiving buffer, sending window and receiving window. So this is the sending buffer or sending window. And now here we are going to store the bytes. Here we are going to store the bytes. And let's suppose the first byte sequence number is X. Let's suppose the first byte sequence number is X. And the first byte sequence number is X. Then second byte is X plus 1, X plus 2, X plus 3. Yesterday I told that it is started with 0, but it is not actually started with 0, it is started with random number. It is started with random number. So let's suppose the random number is X. So the first byte sequence number is X, then X plus 1, X plus 2, X plus 3 and so on. In this fashion there is a number 2 to the power 32 minus 1. In this fashion the next byte sequence number is 0. Why? Because the 32-bit sequence, 32-bit is having largest sequence number is 2 to the power 32 minus 1. And then 0, the next byte is 1 and so on. After that the value X is repeated. After that the value X is repeated. So if we are using 32-bit sequence number, in data link layer always sequence number started with 0. 0, 1, 2, 3, n minus 1 and then 0, 1, 2, 3, n minus 1 and like this. Here sequence number is also going to repeat 0, 1, 2, 3, 2 to the power 32 minus 1 and then 0, 1, 2, 3, 2 to the power 32 minus 1 and 0, 1, 2, 3. But the sequence number according to sending buffer. So we are going to assign the sequence number to each and every byte. Okay. Now in transport, in TCP, the sequence number is not going to start with the in TCP sequence number is not going to start with 0, it is going to start with random number. Why the random number? You can get the answer at the time of TCP connection establishment. In TCP connection establishment you will get why the number is started with the random value. So assume that the number first byte sequence number, first byte of this sending buffer, the first message, first byte sent by this process, that byte number is randomly assigned X, then X plus 1, X plus 2, X plus 3 and the number is increasing, and by increasing the value 1 by each and every byte there is a largest number, 32-bit largest number, that is 2 to the power 32 minus 1. After that the next byte sequence number is wrap around. What is the meaning of wrap around? After the largest number we are going to turn to the 0, 1, 2, 3 like this. So after that wrap around and 0, then 1, 2, 3. But the same sequence number which is first byte sequence number is repeated. Yes, it is repeated, but before that the previous byte sequence number is X minus 1. So tell me here to here. So tell me here to here, this X2, this X minus 1, this X2, this X minus 1, how many bytes? How many bytes? Number of bytes. Number of bytes. So tell me the same sequence number is repeated. So X is the sequence number, starting sequence number, and same sequence number is repeated in between. How many bytes? If I am telling that 0 to 2 to the power 32 minus 1 and then 0 repeated. Let's suppose the value of X is 0. So 0 to 0 is going to repeat. So 2 to the power 32 bytes. So similarly here X is going to repeat it again. Till that how many bytes? Number of bytes is 2 to the power 32 bytes. Why 2 to the power 32 bytes? Why? Because the 32-bit sequence number used in the TCP header. 32-bit sequence number used in the TCP header. So it is telling that this byte is encapsulated in the first segment. This byte is encapsulated in the first segment. Okay, then what happened? Next. So this byte is encapsulated in the first segment, and then next few bytes in next segment, next few byte in next segment, next few byte in next segment. In such a fashion, what happened? here we are encapsulating the byte, we are putting the bytes in the payload field of respective segments one by one, releasing this byte whose sequence number is X. So basically sequence number is repeated. Basically the sequence number is repeated. It is basically wraparound. So sequence number is repeated. Then what happens? When this byte is entered in one sequence, so this byte is entered in one segment. So what happens? There might be clash comes in the picture. There is a clash comes in the picture. What if receiver is going to send acknowledgement? So the same byte number is identified with the X and the different byte number is identified with the X. So the same sequence number is going to represent two different byte. Same sequence number is going to represent two different byte, and that should not be occur. That should not be occur. So what we have to do? What should TCP do? So TCP is going to maintain the segment lifetime. TCP is going to maintain the segment lifetime. So the segment lifetime is basically what? This byte is having sequence number X and this is carrying the sequence number X, and this is applicable, this is valid till this sequence number is not repeated. This is valid till the same sequence number is not repeated. Means the amount of time required to transmit 2 to the power 32 byte, that is a become maximum segment lifetime. That is a become minimum value for maximum segment lifetime. Means a segment in which this byte is entered, that segment is, the segment lifetime is on till this byte does not transmitted over the channel, When this byte is transmitted over the channel, 100% this byte, 100% the segment, 100% the segment who is carrying this byte, that lifetime is expire. So that lifetime should not be getter, lifetime should be valid till that value. So it is telling that the one particular segment lifetime is totally depend on when the sequence number is going to wrap around. So here the concept is that maximum segment lifetime, MSL. So what is MSL? It is also known as wrap around time. So what is wrap around time? The same sequence number is going to repeat it. Yes, it will be repeat, but the previous sequence number should be invalid till that number is come in the picture. Previous number should be invalid till the next number come in the picture. So that life should be expire, lifetime should be till that the next number is come in the picture. So here, and duration for a TCP segment can exist in an inter-network system. A TCP segment can exist in an inter-network system, that duration. So that duration is basically known as maximum segment lifetime. So that is known as maximum segment lifetime. So here basically, suppose size of sequence number field is k bit in TCP header. Suppose the size of sequence number field in is k bits in the TCP header. In the TCP header, the size of sequence number is k bits. Generally, TCP is having 32-bit sequence number. But here I am putting the equation in terms of k bits. Why? Because in GATE they are going to ask a new protocol apart from TCP, in which what is the minimum bit required for sequence number field. Generally TCP is having 32-bit sequence number, but in GATE they can ask for different protocol also. So here let's suppose sequence number field is k bit long. Let's suppose sequence number field is k bit long. So using k bit sequence number, how many byte we can address? 2 to the power k byte we can address, and then same sequence number is repeated after 2 to the power k byte. Here sequence number is 32-bit long, so the same sequence number is repeated. After 2 to the power 32 byte. So the same sequence number is repeated after 2 to the power 32 byte. So what is here? So here basically what? If I am telling that k bit sequence number is there, so the maximum segment lifetime is basically what? Amount of time required to transmit these number of bytes, and it totally depend on what? It totally depend on bandwidth. It is totally depend on bandwidth. So here basically what? The minimum value for maximum segment lifetime is determined by what? How many bytes we can transmit it, how many bytes we can transmit it, sorry, how in how many time these number of bytes are transmitted. So this is the maximum segment lifetime and this is the minimum value. Why minimum value? Here I am writing this is a MSL. Basically this is a minimum value for maximum segment lifetime. The maximum segment lifetime can be greater depend on if if the sender is not having data. Let's suppose sender is not having any data. If sender is not having any data, then so the sequence number is repeated little bit late. Sequence number is going to repeat little bit late. But we are assuming that the worst case. What is worst case? Let's suppose the TCP sender, the process is having sufficient data and it is going to send back to back transmission is going on, and back to back transmission is going on and no any gap is there and continuously it is sending the data and the same sequence number is repeated. So the answer is that 2 to the power the answer is that 2 to the power k bytes is transmitted using the bandwidth. So bandwidth is given in the question in the exam. In the exam, if question is coming, they are giving the bandwidth. So these number of bytes is transmitted in what amount of time? Total number of bytes divided by data transfer rate. Total number of bytes divided by data transfer rate. Total number of bytes transmitted divided by data transfer rate, you will get transmission time, and the transmission time is become maximum segment lifetime. And whatever the value we are getting, that is the minimum value for maximum segment lifetime. Sometimes what happen? Sometimes process is not sending data back to back. Sometimes process is not having data, it is getting the data little bit late. So okay, same sequence number is repeated, not early, little bit late. It depend on how much speed process is sending data. But we are assuming that let's suppose process is having data, sufficient data, and it is sending back to back. So this is the value is derived as maximum segment lifetime. Any segment is valid segment, any segment will be treated, or its life is valid, life is on till this time. After that the segment will be treated as a expired. So after that segment will be treated as a timeout or life is expired kind of. In case of TCP, the value of k is 32. In case of TCP, the value of k is 32. So using this we can able to derive the value of maximum segment lifetime. Better to understand the concept with the one question. So here I am giving you one question. GATE 2018 IIT Guwahati. IIT Guwahati question is there, and very easy question is there. You have to use that equation. Here I am giving you pole. Integer question is there. Here I am giving you 90 seconds. That is sufficient to give the answer of this question. Okay, poll is not showing, so no any issue. What is the answer you are getting? Right over the comment. What is the answer you are getting? Right over the comment. I'll put remark, so the team will work on it. Poll is not working. So if poll is not working, then do any significance of checking this. But so what answer you are getting? Right over the comment. It's nothing, just calculation only. Shubham is getting answer 8. So Eunice is getting answer 32. Consider a long-lived TCP session with an end-to-end bandwidth of 1 Gbps, that is 10 to the power 9 bits per second. The session start with a sequence number of 1, 2, 3, 4. I told that starting sequence number is not 0, it's a random sequence number, that value is x. The value of x is given 1, 2, 3, 4. Starting sequence number is 1, 2, 3, 4. Okay. The minimum time in second rounded to the closest integer, and before this sequence number can be used again, means the same sequence number is going to repeat and the same sequence number is going to repeat it. Minimum time for which the same sequence number is going to used again. 1, 2, 3, 4 is a sequence number and the same 1, 2, 3, 4 is going to use again after what amount of time. So here basically the k bit sequence number and the value of k is 32. Why? Why? Because it is telling that a long-lived TCP session. In case of TCP, sequence number is 32-bit long. Fine. Now, it is asking that the same sequence number is going to use again. Means we have to tell the wraparound time, or basically we have to tell the maximum segment lifetime. So, the wraparound time, is also become maximum segment lifetime is what? And 2 to the power k bytes. 2 to the power k bytes divided by bandwidth. In this question, the bandwidth is given. In this question, the bandwidth is given 1 Gbps. One Gbps. The 1 Gbps is already given here. 10 to the power 9 bits per second. So here we are putting this value, and the sequence number is 32 bit long. So if we are keeping this value, so this is 2 to the power 32 bytes and divided by 1 Gbps, means how much time required to transmit 2 to the power 32 byte using this bandwidth. So here we have to convert this byte into bit, 2 to the power 35 bits and divide by 10 to the power 9 bits per second. And in exam, scientific calculators are there, you can apply and the value in the second. So here I am solving it. 34.35. So it's a 34.35 and that is a second. But in the question it is telling that we have to give the answer. We have to give the answer in the rounded to the closest integer. So rounded to the closest integer, the 34.35, if we are taking nearest, then it will become that 34 second. So and the answer of this question is 34 second. Nearest means if this value is less than 0.5, then 34. If this value is greater than 0.5, then 35 will be answer. So let me check if there any calculation mistake or not. So 34.35. Yes. So Shubham Kumar Shukla is telling, sir, we can convert GB to 2 to the power 32 bits. No. Here it is directly written, and you missed my that flow control class. You have missed my flow control class. In the flow control class, I clearly tell that the data transfer rate is a frequency. Data transfer rate is a frequency, and frequency always been analog, and that's why it is 10 to the power something. And the data is always be in the digital. So digital means it is in the memory. So always KB MB is in the power of 2. So in case of digital 2 to the power, in case of analog 10 to the power. So don't do that mistake. I have already explained in the flow control chapter. So you missed that class. If you see that lecture, you will got to know GBPS is not 2 to the power 30. 1 GB is 2 to the power 30. 1 GB means 2 to the power 30 gigabyte, but 1 Gbps is 10 to the power 9 bits per second. So here the answer of this question is 34. So very easy question. Very easy question. Only calculation is there. If someone is knowing the concept, in TCP sequence number is 32 bit long, and the same sequence number 1 2 3 4 number is given you for confusion only. Let's suppose sequence number X and the same sequence number X is repeated. After how many amount of time? Definitely if back to back data is transmitted, then using this bandwidth, this is the minimum time to repeat the sequence number. Why it is written the minimum time? Why it is written the minimum time? The reason is that if let's suppose process is not having data, then there is some kind of delay. So the sequence number is repeated. But not before 34 second. It might be possible beyond this value also. So it depends on how frequent we are sending the data. If we are not sending frequently, then sequence number is repeated little bit late. But if we are sending data back to back frequently, then this is a minimum time to repeat the sequence number. So this is the way. Now in exam, there is some other variety of questions are also coming. What? Let's suppose the here in this equation, if the sequence number, if we know the value of k, sequence number bits, and we know the bandwidth, then we can able to find out the wraparound time. We can able to find out the maximum segment lifetime. If the maximum segment lifetime value is given and bandwidth is given, can they ask minimum number of bits required for sequence number field? Can they ask a minimum number of bits required for sequence number field? So let's suppose in the same picture, let's suppose the sequence number field is sequence number field size is k bits. Already I mentioned in case of TCP it's a 32 bit. But let's suppose we are going to design a new protocol. Similar like TCP. In that header, in that protocol, new TCP header, how much sequence number, how much bits, how many bits sequence number field should be there. So the value of k we have to find it out. And let's suppose the maximum segment lifetime is given and bandwidth is given. So there is a maximum segment lifetime is equal to what? 2 to the power k bytes divided by bandwidth. So it is basically, if we have to find out 2 to the power k bytes is equal to maximum segment lifetime into bandwidth. And if we want to take log at both sides, so can I say that the value of k is equal to what? Log base 2 maximum segment lifetime into bandwidth, but and this multiplication should be give the number of bytes, not number of bits. This multiplication should produce number of bytes, not bits, because here I am assuming 2 to the power k bytes. So basically it is telling that how many bytes we can transmit, how many bytes we can transmit in one maximum segment lifetime, how many bytes we can transmit in one maximum segment lifetime. So better to write in different way. If sequence number is k bit long, so better to write that how many number of bytes transmitted in one MSL or wraparound time. So the better way to write that, and the better way to write that, in spite of writing that, total number of bytes, total number of bytes can be transmitted in one maximum segment lifetime or wraparound time. And that is equal to what? And that is equal to maximum segment lifetime into bandwidth. These number of bytes and these number of bytes, the answer should be in bytes. The answer should be in bytes. And these number of bytes we can transmit in one MSL. If in exam question is coming, minimum number of bits required for sequence number feed. Minimum number of bits required for sequence number field. And that value is k. So you have to write log base 2 number of bytes transmitted in one MSL. Number of bytes transmitted in one maximum segment lifetime. And you have to take the ceiling. Space is issue. And that is equal to what? Log base 2 number of bytes transmitted in one MSL. And we have to take the ceiling, and the answer is in bits. So there are two questions in the gate history based on this logic. Number of bytes transmitted in one MSL. So if you are understand, basically we have to find out how many minimum number of bits required. So it's totally depend on how many bytes we can transmit in one segment lifetime, how many maximum byte we can transmit in one wraparound time. Before going to repeat the same sequence number, how many bytes we can transmit? These number of bytes we can transmit. To address these number of bytes, how many bits required? To address these number of bytes, how many bits required? This is a way. So there is a question in the gate 2022. Poll is not working. Poll is not working. Poll is not working. So better take the time and write your answer over the comment. Take the time and write your answer over the comment. Shubham has given the answer 38. Nishant has given the answer 42. So let's check what the calculation and answer you are finding it out. It's totally based on calculation. So concept is very easy. Consider the data transfer using TCP over 1 Gbps link. So is in this question bandwidth is given 1 Gbps. 1 Gbps. And in case of bandwidth, G means 10 to the power 9 bits per second. In this question, the assuming that the maximum segment lifetime is set to 60 seconds. The maximum segment lifetime is set to 60 seconds. Okay. So maximum segment lifetime is set to 60 seconds. Now it is asking that the minimum number of bits required for sequence number field in the TCP header. So although TCP header is already containing the sequence number, that is 32 bit, but it is asking that, let's suppose we are going to design a new protocol similar like a TCP. In that header, how many bit sequence number is required in this scenario? So here we have to find it out. First, number of bytes transmitted in 1 MSL. number of bytes transmitted, number of bytes can be transmitted in one MSL. So basically what it is, bandwidth into MSL. So it is basically what, bandwidth into so here we are putting the value 10 to the power 9 bits per second into 60 second into 60 second. Then second and second get cancelled. 6 into 10 to the power 10, 6 into 10 to the power 10 bits. But remember, we have to find out that number of bytes transmitted in one MSL, not number of bits. So we have to convert this value. We have to convert this value into bytes. So if we are converting this value into bytes, so 6 into 10 to the power 10, 600 divided by 8. $75 into 10 to the power 8 bytes. 75 into 10 to the power 8 bytes. Now, as per the question, a minimum number of bits required for sequence number field. Minimum number of bits required for sequence number field. So do not put this value, this is in bits, put this value, this is in bytes. So here we have to take log base 2, 75 into 10 to the power 8. These number of bytes we are transmitted, and these to address these number of bytes, how many bits are required? We have to take log. So 75 into 10 to the power 8, and we have to take log. You have to use scientific calculator. We have to use scientific calculator. Log 2 75 into 10 to the power 8. Log base 2, 75 into 10 to the power 8. It's a 32.80. It's a 32.80. 32.8. And let's check any calculation mistake is there or not. Hmm, 32.8, right? So 32.8 is the answer. And then we have to take the seal. So correct answer is 33 bits. Correct answer is 33 bits. So the answer of this question is that if we are going to design if we are going to design a new header, if we are going to design a new new protocol like a new TCP, and that in that header part, as per this constraint, the sequence number should be 33 bit, not 32 bit. If we are keeping sequence number 32 bit, then we are not going to maintain the wraparound constraint. Basically it is telling that to prevent the sequence number space from wrapping around. So it is telling that the sequence number is going to repeat only after the maximum segment lifetime, not before the maximum segment lifetime. So answer of this question is 33. So this type of question asking in the exam. So we have seen two different variety. In the previous part, the wraparound time is asking. In this part, wraparound time is given, maximum segment lifetime is given, and then they are going to ask how many bits required for sequence number field. So similar variety of questions is already asked. So this is 2022. In 2022, and that 19 is Chennai, 20 Delhi, 21 Bombay, 22 is Kharagpur, 23 is Kanpur, 24 is ISC. So this is a Kharagpur's question, and then thus one question is for homework. One question is homework question for you. In the next year, GATE 2023, Kanpur is asking this question on the same topic. IIT Kanpur is asking the question on same topic, but it modified the definition of the question little bit, but the same concept. But the same concept is applied here. So this is the homework question for you. It better clearly tell that the new reliable byte stream transport protocol like TCP, it is named as MyTCP. So it is telling that similar to TCP, we are going to design a MyTCP protocol, and that MyTCP protocol header, how many bit sequence number is there, we have to find out in the same way. So here some students are having confusion that sir, in TCP sequence number is 32 bit long, then how you are giving the answer 33 bit. Basically this question is not clearly telling that we are going to modify the TCP header. We are going to modify the TCP header, and as per this scenario, the minimum number of bits required for sequence number field, now this time you have to give the answer 33. So the 32 value is set using some assumption, and now as per that input the answer should be 33. Clear? So this is the homework question for you. Take the time and solve it. Don't do the calculation mistake. You have sufficient amount of time in your home. So in this way we are going to complete this topic, basically maximum segment lifetime. So it is telling that what is the one segment lifetime. Basically it's a segment lifetime means it is a equal to wraparound time. Our same sequence number is going to repeat till that same sequence number is going to repeat till that a segment can be applicable or its life is valid. Its lifetime is on, it's not expire. But once the same sequence number is going to repeat it, and the segment is the previous segment in which the same byte is there, it's gone expire kind of. So it's also known as wraparound time. Same sequence number is repeated. Yes, it's possible, but till that what amount of time, how many bytes we are sending, and there are the variety of questions asking in the exam. So these variety of questions we have solved. One variety is this, and other variety is this, and the same variety is repeated in 2023. That is a homework question for you. So any doubt, then ask. If no any doubt, then we are moving to the fourth word of the TCP header. In TCP header we have seen what? In TCP header we have seen first word source port number, destination port number, second word is sequence number, third word is acknowledgement number. Now we are moving to the fourth word. So fourth word is having that header length, and then 6 unused bits, and then 6 flag bit, and then after that window size. So initially the header length and then 6 flag bit. What is the use of those 6 flag bit? We are going to discuss those 6 flag bits. So any doubt, then ask. No any doubt, then give the clear signal. No any doubt, clear? Yonis is telling clear, Pradeep is telling clear, okay. So let's move to the header length. So header length is nothing new for you. You have already seen the IPv4 header. You have already seen the IPv4 header. In IPv4 header, header length field is 4-bit long. Here is also header length field is HLN field is 4-bit long. Only the position change. In IPv4, it is the last 4-bit of first byte. It is the last 4-bit of first byte, but here it is the first 4-bit of the fourth word. First 4-bit of the fourth word, fourth row. So header position is changed. It is 4-bit long and header length is shortly abbreviated as HLN, and the size of header, it is mentioning the size of header in words, and the word of 4 byte, word of 32-bit, word of 4 byte. And why we need to mention it? Why we need to mention it? Because there is a place for optional header. There is a place for optional header. Because of that, we have to mention the header length. Whenever header size are variable, we need to mention it explicitly. In UDP, header size is fixed. No need to mention it explicitly. It is implicit, always value 8, and it can be asked in the exam. So you have to remember UDP header size is 8 byte. Then here the minimum header size, that is a base header. So base header is having 5 words. We have seen 5 word is a base header. So 5 word, if we convert in byte, then it's at 20 bytes. Then what is the maximum header size? So what is the largest value using 4-bit unsigned int? So 4-bit unsigned int range is 0 to 15, but 0, 1, 2, 3 is not possible. 4 is also not possible. The minimum value of header length should be 5. So minimum value of header length should be 5, and the largest value of header length can be 15 words. So 5 to 15 words. 5 to 15 words, and then the maximum header size is 15 words. If we convert in byte, it is 15 into 4, that is a 60 byte. So 15 words, that is a 60 bytes. So it is the same as IPv4 header, nothing new, nothing change, only position change. Everything is same. So I am not going to give more time over it. It's easy for you if you have already covered IPv4 header. So here we are moving to the most important topic in the TCP, that is a TCP operation. And that TCP operation, what is TCP operation? So basically TCP operation is nothing. We are sending the data. In case of UDP, we do not need to establish a connection. Only we have to send the data from one UDP socket to other UDP socket, and we are getting reply from that UDP socket to this UDP socket. Nothing new. Only simple communication is there. And UDP socket, one UDP socket is going to communicate with other UDP socket, obviously with the help of IP protocol. So UDP protocol is going to generate UDP packet and giving to IP. IP is taking the packet from one machine to other machine, and then other machine IP is giving the packet to UDP, and UDP is forwarding to the process. That's simple. In case of UDP, everything is simple, but things are going to change in case of TCP. In TCP, data transmit operation is not that much easy. The TCP operation is basically what? Data transmission operation, everything. So in TCP, we have to establish a connection between two TCP socket. So one TCP socket is going to exchange data with other TCP socket, and remember, a UDP socket is different and TCP socket is different. In next class we are going to see the socket programming, network programming, how UDP and TCP sockets are created. The programming interface is different for them. So one TCP socket and UDP socket is different. So in case of UDP, things are simple, but in case of TCP, two TCP sockets, one TCP socket is going to communicate with other TCP socket. First, we have to make them connect logically. We have to create a connection state, both the end. Then only we can do the communication, and once our communication means data transmission is over, then at the end we have to release that connection. Why? If we are not releasing that connection, that socket is binded to each other. It's not, they are not going to become free to communicate with any other socket. So we have to release the connection so that these sockets are free and going to make communication, going to make connection with other socket. So once you will free with one, then they can only communicate with other. So one to one mapping is there, no many to one, no one to many is there, one to one is there always. So and the TCP operation, 3 phase of TCP operation is that connection establishment. And for connection establishment, there is a three-way handshake process that establishes the connection between two TCP sockets. Once the connection is established, then we have to perform the data transfer. Data transfer is the mid step, mid operation, but mid phase. But the third, once the data transmission is over, data transfer is over, the communication is over, we have to release the connection termination. And for connection termination, both the TCP socket will do four-way handshake process, will gone through four-way handshake process that closes the connection. So to establish the connection, three-way handshake. To close the connection, four-way handshake. And now what is this three-way handshake? What is this four-way handshake? This we are going to study in more detail. In exam, you are having the question, you are in the GATE exam, already question asked on three-way handshaking 2 to 3 times. There is a one-time question asked on four-way handshaking. I was assuming that the four-way handshaking is not going to ask in the GATE, because never asked in the GATE history, but in 1 year they put the question on this also. So we have to include this also, and that time onwards we started teaching four-way handshaking also. So there is a problem with computer network, and they don't leave any topic, they are asking their question randomly on any topic, any frequent topic. So no any static kind of thing, the question definitely come on from this topic and this topic, this topic. They can dynamically ask the question from any topic. So there is a fixity in computer network. 60% topics are static, like CRC, like IPv4 header, like IP addressing, like CSMA/CD, and then TCP condition control. 60% topics are fixed in computer network. 60% questions are come on those fixed topic. Those I am going to cover in the crash course. So if you have covered this session, that's okay. But if you will get time, when my crash course is going to start in YouTube, I'll cover those topics only, those 60% topics only, in which questions are coming in the GATE. So not those 60% topics, on those topics in which the high probability of questions are coming, and the topic in which questions are coming only one time or two time. Here I am teaching in the paid batch in more detail, but in crash course I'll skip those part, because here I am going to show and highlight those things only which is more relevant for exam point of view, but not that much relevant. So here three-way handshaking I'll definitely cover in the crash course, but four-way handshaking I'll skip in the crash course, because only one question in the GATE history. So that's why the crash course is a compact course, but the compact course is only for those who want to secure, who want to get 40, 45, 30, 40, near about 40 to 45 marks in the GATE exam. But those who want to go 60 plus or 70 plus, then they have to go with the detailed study, everything, because you do not know when the question comes from four-way handshaking. Mostly the chances most chances that question comes from the three-way handshaking, but there is a small chance from the four-way handshaking also, because in GATE history they already asked the question. So that's why the computer network becomes lengthy for you. You are finding out that 2 months completed and our subject is not completed. Still it will take more 7-8 lectures to complete the subject. So that's the thing, is that few topics are there on which frequency is 1 or 2, but I have to teach, that's why it becomes lengthy. So now three-way handshaking to connection establishment, and then once three-way is completed, then we will come to the four-way handshaking connection termination process. So here it is clear, two TCP socket is going to establish a connection. But remember, the TCP socket who is going to initiate the TCP connection is known as TCP client, and the TCP socket is getting that connection, it is known as TCP server. So the TCP is sending the connection request is treated as client, and thus TCP is getting the connection request. So one TCP is sending connection request, one TCP is receiving connection request. Sending become client, receiving become server. So there is a client server kind of thing. So here we are putting the word TCP client and TCP server. The TCP who is going to send the connection request become client. For us, terminology is set client, and the opposite who is receiving the connection, that is become server. Terminology we are setting for communication, TCP client to TCP server. Then So here the TCP connection establishment process. Here connection establishment between TCP client and TCP server. So basically the term is that one TCP is sending the connection client and one TCP is going to accept that connection, receive the connection request, accept the connection server. So three-way handshake process. So it's a basically three-way handshake process. What is this three-way handshake process? Always TCP client initiate the connection request to TCP server. Now server can be anything, like when we are going to make a communication between HTTP client and HTTP server, and HTTP protocol is telling to the TCP, HTTP protocol is telling to the TCP, make the connection first and then we will do the communication. So in case of HTTP client want to communicate with HTTP server, but the client is telling to the server, client is telling to the TCP, you are the TCP client and you have to establish a connection with that TCP which is reside in the HTTP server. So the server side TCP is TCP server and client side TCP is TCP client. So before going to make a application layer communication, we have to establish a TCP connection between client and server. So client is going to make a request to server. So here always TCP client initiate the connection request, true. Now the sync packet. So basically these 2 points we are going to study little bit late. So here the TCP connection establishment, in TCP connection establishment I have to put timeline. I have to put timeline at the client side and server side. So this is the timeline. So here let's suppose this is the TCP client and this is the TCP server. This is the TCP client and this is the TCP server. And then let's suppose TCP client is sending the connection request to TCP server. TCP client is sending the connection request to TCP server. Fine. And then what happened? In this connection, the TCP segment is sent by the client to server. In this connection, TCP segment is sent by client to server, and TCP segment sent by client to server. And in segment, what are the fields are there? So I am not going to write all the information. Let's suppose source port number. So obviously the process the process which want to communicate with other process want to establish a TCP connection between them. So source port number of source process, destination port number of destination process. So basically server process and client process, source port number and destination port number, they are going to make a TCP connection, then only their communication start. Okay, source port number and destination port number is not a big issue for us. So obviously the process which is going to establish a TCP connection, that process is source port number, and the process is telling to make a TCP connection with a server process, server side TCP. So that server process port number is that. So source port number and destination port number is fixed. Not fixed means determined by the source process. Now sequence number is important. Sequence number is important. What is telling sequence number? Sequence number. So what sequence number we have to put? 0? No, do not use 0. Why? The reason is that whenever we are making a connection request, every time we are using 0. And let's suppose we are going to make another TCP connection, and let's suppose we are going to make another TCP connection with same server. Might possible, Might possible that same client is going to open multiple TCP connection with same server. Might possible same client is going to open multiple TCP connection with same server. Like that, you have purchased a SIM from one service provider Jio, and you are going to purchase another number from the same service provider. That's possible. You are taking two numbers from that service provider. Similarly, one client is going to make a TCP connection between client and server. So one port, one socket, and the other server TCP server socket. So client socket, server socket is connected with TCP connection. Let's suppose the other socket, the other socket of same process is going to create another TCP connection. Then what? So in this way, whenever two requests are going to reach at the server with the same sequence number, server might get confused. That's why we are choosing a random sequence number. That's why we are choosing the random sequence number. It is known as initial sequence number. So what is initial sequence number? Here you just see this part, initial sequence number. Here I am going to discuss this part later. Both TCP client and server randomly chooses their initial sequence number. Both TCP client and server randomly chooses their initial sequence number to prevent from some kind of attack. So some kind of attacks are there in internet. You can find out that how these attacks are performed. So sometimes of intentional attack, some kind of unintentional attack. So basically it is telling that better to choose initial sequence number random. Like in the previous question, the sequence number is 1 2 3 4. In the gate question, the sequence number is 1 2 3 4 as a starting sequence number. So similar like a randomly client and server will choose initial sequence number randomly. So here as per this logic, here the client will choose a random number. Let's suppose choose a random number, but the number should be between 32-bit range, 0 to 2 to the power 32 minus 1. You have to choose a random number, 32-bit random number. So what to do? Write 32-bit randomly. 1 0 1 1 0 0 1 1 1 1 0. Like that 32-bit number, 32-bit you have to write, and what is the decimal number? Accordingly that number is become your initial sequence number. So here initial sequence number, I am not choosing a large number because it's difficult to write here. I am not choosing the large number, it's difficult to write here. I am choosing a small number. Let's suppose the initial sequence number I have chooses 70. I have chooses initial sequence number 70 randomly. Okay, the random number is there. Now, what about acknowledgement number? See, this is the start. At the begin, the client does not have anything to acknowledge. At the begin, client does not have anything to acknowledge. Okay, acknowledgement field is garbage. Okay, acknowledgement field is garbage. But how to determine acknowledgement field is garbage? So we have to put acknowledgement bit 0. We have to put acknowledgement bit 0. So here I am writing ACK bit. ACK flag. See, acknowledgement number is something, acknowledgement flag is something. So here I am writing acknowledgement flag. Means acknowledgement flag is off. It means it is indicating that the acknowledgement number, 32-bit acknowledgement number is containing a garbage value, no any relevant value, garbage value. But this is the connection request. This is a basically connection request. So here sync bit should be 1. What is sync bit 1? SYN in the 6 flag bit. The 6 flag bit is URG urgent flag, ACK acknowledgement flag, P push flag, R reset flag, and then SYN sync flag, and then FIN finish flag, sync flag and finish flag. So sync flag is on and rest of all the flags are off. Means URJ is off, ACK is off, push is off, reset is off, finish is off. All the flag is off except sync is 1. So I do not need to write ACK. I do not need to write ACK is on. ACK is off, but here I am writing for your understanding. And this is the connection request. So who is going to put this connection request? So this is the connection request, and this connection request is basically sent by the TCP client. So this connection request is basically sent by TCP client to TCP server. So connection request is always gone in the form of segment. But remember, this segment does not contain any payload. This segment does not contain any payload, only header. Only header, no any segment. It's like that a tractor is going, but no, without any trolley. It's like that tractor is going without any trolley, and if the tractor is going with trolley, means the trolley is a payload. Trolley is a payload. So tractor is without trolley, with trolley. So both the cases are there. So segment is basically header only or header with payload. So here we are not sending any data, only header, because connection request. So only 20 byte TCP header, only 20 byte TCP header, 5-word TCP header, in which sequence number is initial sequence number, sequence number is initial sequence number, and then acknowledgement number is garbage, ACK flag is off, sync flag is on. Basically it is known as sync segment. It is known as synchronized segment. Sync, full form of sync is synchronize. So it is a synchronized segment which is sent by the client. It is a basically connection request. Now this segment is received by the TCP server. This segment is received by the TCP server. So this TCP segment is prepared and given to the IP. IP is taking the destination IP address, and that IP is putting this segment in the payload part and taking this datagram to the destination IP, and destination IP is giving the header to the destination TCP. So destination TCP is getting the same segment sent by the client. Okay. Now what happened? When this receive what? When this receive connection request. So it is receiving the connection request. Then what? The server is going to determine, server is going to decide whether I am interested in this request or not. So this request is accepted by the server. Accepted or not accepted, both the cases are there. Let's assume positive case, accepted. Later we will discuss not accepted case. So initially we are assuming that the positive case, connection request is going to convert it in accept case. So the server is going to accept the connection. So here so basically here the connection request received, connection request received, and the server is going to accept the request. So here it is going to accept the request. So this is the point and this is the point. So here connection request received, and then server is going to accept the request, and accept means it has to send the accept message. It has to send the accept. So accept from the server side. So server is going to send one segment. Server is going to send one segment. In that segment, and the source port number and destination port number is there. Definitely the server process port number, source port number, client process port number, destination port number. How to get client process port number? Obviously in the receive segment, source port number is a client source port number. So the source is become destination, destination become source in the reply. So source port number exchange. Source port number become destination port number, and destination port number become source port number. So port number exchange. Then it is giving the reply. So in which the sequence number is the most important thing. like client server is going to choose a random sequence number. Like client server is going to choose a random sequence number, means client chooses a sequence number 70 randomly. Okay, client chooses a random sequence number 70 randomly. Server chooses a sequence number 157 randomly. 157 randomly, a random number. No any relation with the client sequence number, randomly. But remember here, does it carry acknowledgement? Yes. The server is acknowledging the client request. Server is sending your this request is going to accept. Your this request is going to accept. So how to acknowledge this segment? How to acknowledge this segment? Obviously based on what? Obviously based on acknowledgement number. So here we are writing acknowledgement number. And the ACK flag is 1. Why? Why ACK flag is 1? Because it is telling that acknowledgement field is not containing garbage value. It is telling that acknowledgement field will containing the acknowledgement number of your segment. Whatever the segment sent by you, I am acknowledging that segment. So basically what? This acknowledgement number is not 70. Although the payload field is not containing any data, but the acknowledgement number is 70 plus 1, 71. The acknowledgement number is 71. So this 71 is signifying that and the server is telling that I am looking for a segment. I am looking for a segment whose sequence number is 71. I am looking for a segment whose sequence number is 71. It indirectly signifying that a segment whose sequence number is 70 received, and that was the connection request segment. So it's a sync segment, connection request segment. It is acknowledging that segment, means that connection request received. And why it is sending the segment? Why it is sending the segment? It is sending the accept segment. It is sending the accept segment, connection accept segment. So the request is going to accept. Now here the sync bit should be 1. Here sync bit should be 1, means it is sending the sync packet, sync segment, synchronized segment, and on reply it is getting the sync segment from the server side. Both are sending sync segment, client to server and the server to client sync segment. Now what happened here? What happened here? The client is received accept message. So accept the request. So basically what? It is sending the connection request and it is sending the accept message. So here the client receive, here the client receive accept message, accept segment. So client receives accept message, accept segment. Then what? The client has to acknowledge this segment. The client has to acknowledge this segment. Why? The client has to acknowledge this segment because this segment is indirectly acknowledging the client segment. So the client segment acknowledges by the server. Now the client has to, and the client segment is acknowledges by the server. Now the client has to send acknowledgement of server segment. The client has to send acknowledgement of server segment. So here what happened? Client is going to send acknowledgement of this accept message. Acknowledgement of this accept message. So basically it's a connection request message. Here acknowledgement arrive. Along with acknowledgement, accept message is there. Accept and acknowledgement are in the same segment. That's why both the flags are on. It has to acknowledge. Client has to acknowledge the server's. Client has to acknowledge the server accept segment, sync segment. So here and it is going to maintain, it is going to put sequence number. What sequence number? The sequence number is 71. Why? Because the server is expecting the sequence number 71, and then acknowledgement number 158. Acknowledgement number 158. Why? Because 157 plus 1, 158. And remember, here ECK flag is on because this is carrying the acknowledgement number. Acknowledgement field is not garbage, but sync flag is off. Sync flag is off. And if client want to send data to the server, now client is allowed to put the data in the payload field, because this is acknowledgement segment, and this acknowledgement segment can carry data also. If you want to put data in the payload field, then it's okay. But remember, the data is going to put in the payload field the first byte of the payload. That sequence number is 71. The sequence number is 71 means whatever the data is going to send by the client to the server, their data first segment, and this is the first segment, this is the connection segment. It does not contain any data. No, any data is allowed here. But you can put data here. And if you are putting data here, then the data, the first byte of the data, that sequence number is 71. So its sequence number is started with 71. So it's always true that if a client is going to choose the initial sequence number 70, definitely that 70 is going to waste because of connection establishment. But the first byte in the sending buffer, that sequence number is 71 onwards. First byte is 71, second is 72, 73, like that. Similarly for server socket is having two buffers, sending buffer and receiving buffer. So if server is going to choose 155, 157 as an initial sequence number, server is going to choose 157 as an initial sequence number, that number is going to waste, and the number after that, that is 158. That is 158. So the server is going to send first data segment in which the first byte of the sending buffer, that sequence number is 158. Do not start with 157, start with 158. So whatever the initial sequence number chooses by the client, its buffer is going to start with the number initial sequence number plus 1, and whatever the initial sequence number chooses by the server, its buffer initial sequence number plus 1. So in the question which is asked in the gate, the sequence number started with 1, 2, 3, 4. The sequence number started with 1, 2, 3, 4. It means whatever the TCP, the initial sequence number is 1, 2, 3, 3. Initial sequence number was 1, 2, 3, 3. That's why it started with the sequence number 1, 2, 3, 4. So here the value x, the picture I have shown in which value is x. So the x means the initial sequence number was x minus 1. That's why the buffer started with sequence number x. First byte sequence number is x. So like this. So 71 is the first byte sequence number of the first segment. If you want to keep, then it's okay. If you don't want to keep, then you can start sending later. But the protocol is saying do not send acknowledgement only, send acknowledgement with data. But you are not allowed to send any data when sync flag is on. You are not allowed to send any data when synchronized flag is on. If sync flag is on, only header, no payload. If sync flag is on, only header, no payload. But if sync flag is off, then you are allowed to send payload. You are allowed to send data in the payload part, because it is not going to send connection request, no any connection accept message. It is just acknowledgement of accept message. Now here I am going to explain these points. Initial sequence number is only when sync flag is on. Whenever sync flag is on in the packet, synchronized flag, that is known as sync flag. Sorry, that is known as sync segment. So whenever sync segment is sent, whenever sync segment is sent, then what? In the initial sequence number, the both client and server choose initial sequence number randomly, and here one line is written that you can understand now, right now. Sync packet consume one sequence number. Sync packet consume one sequence number. You can see here the number 70 is consumed by the sync packet, and the first byte sequence number started with 71. The number 157 is consumed by the sync packet, and the first byte sequence number from the server side is 158. So the client side first byte sequence number is 171 and the server side first byte sequence number is 158, like that, because of their random. So whatever the random value chooses by the client as a ISN, that value plus 1 is a first byte sequence number, and whatever the random value chooses by the server as a ISN, that value plus 1 will become first byte sequence number in the sending buffer. So here you will find out that this is the sync packet, this is a sync plus acknowledgement packet, and this is the only acknowledgement packet. No sync is here. This is the three-way handshaking. This is the three-way handshaking. Now I am going to put TCP state. So basically in TCP, what I was telling, in TCP client and server, in TCP client and server, we have to create a logical connection. We have to create a logical connection between two sockets. It is a connected socket and state information is going to maintain by them. State information is going to maintain by them. So here we will see in the socket programming, but before that, the TCP server always be in the listen state. TCP server always be in the listen state. TCP server always be in the listen state. Why? Because server is always ready to read, ready to listen client request. So TCP server is always be in the listen state. Then the client is in the passive mode. Client is in the passive means client is not always on. Whenever client want to connect with the server, it's on, and then it is going to make the connection request. So make the connection request, and when client is going to send the connection request, so before that client does not be client is was shut down or closed or off, whatever, client come in the picture and immediately send the connection request. So client state started with what? Client state started is that sync send. So there is the states transition at both client side and server side. So there is a state transition diagram. Like in Automata, states are there. Every transition will perform this, every transition will jump from one state to other state. Similarly in TCP client and similarly in TCP server, both are maintaining different states, state transition. So client side different state transition diagram, server side different state transition diagram. So initially server is in the listen state, and what happened? Client will come in the picture, and the first state from the client side is sync send. What is the first state at the server side is listen. Now when client is in the sync send, it make the connection request, and the request received by the server in which state? Listen state. Server receives the request in the listen state. Server receives the request in the listen state. Then what server will do? Server is going to check whether can I able to accept this request? Yes. If it is able to accept this request, then it is sending the accept message, sync plus acknowledgement. So now here the server is going to in one state that is known as sync receive. Sync receive means I have received a sync packet from the client, and I acknowledges that sync packet, and I also send the connection request. I also send the accept message from my side, but my state is not established yet. My state is not established yet. I have accepted the connection, I have sent the sync packet, along with the acknowledgement packet, and the server state is that sync receive from the client side. Now what happened? When the client message, when the client receive the server message, and this is the accept message from the server side, because server is acknowledging your connection request, server is acknowledging your sync packet, and server is sending their sync packet. So server is acknowledging your sync packet and server is sending their sync packet. So it is a symbol connection established. So basically what here, the client is turned into the step that is established. So here the step is established. So here the client is turned into one step. So basically because of this state, initial state is that sync sent, and because of this transition have happened at the client side and state change established. And in established state, communication is going on. In established state, data transmission is going on. And see here, this is the acknowledgement, and this acknowledgement packet is carrying the data in the payload part. Why? Because this is not a sync packet, this is normal packet, data packet. Then what happened when the acknowledgement arrive here? What happened when the acknowledgement arrive here? Whose acknowledgement? This sync packet acknowledgement. This sync packet acknowledgement arrive here. When this sync packet acknowledgement arrive here, then the server is saying that okay, client is acknowledging my sync segment. client is sending client is sending acknowledgement of mine segment, sync segment. Okay, so based on this acknowledgement number 158, the server is going to convert its state and telling that now my state is also established. And now my state is also established. So here you will find out that initially server is in the listen state. Then what happened? Client started with the sync sent and its sync arrive here, and when the server is sending its sync packet, it turned into one state, sync receive. And when the server is in sync receive, when server is in the sync receive, and when server is in the sync receive, it is client is receiving the sync packet. That time client is doing transition sync send to establish, and during establish, initially it is sending the acknowledgement of this sync packet, and when this acknowledgement received by the server is moving transition, server is doing transition from this state to this state. So here the client reaches in the established state in one transition only, this to this, initial state to second state, but the server reaches to establish in two transition. First transition, this state to this state, and second transition, this state to this state. So both the client and server are in their established state. In this state transition, the second state is established. In this state transition, third state is established. So both are in established. So they are sending the data, sending acknowledgement. It is sending data, it is sending acknowledgement. But remember, sequence number is started with 71, and whenever it is sending the data, sequence number is started with 158, and accordingly a segment is carrying acknowledgement or not, depend on whether the party, one particular end, is having anything to acknowledge or not. If they do not have anything to acknowledge, then it is okay. If they are having something to acknowledge, then put the acknowledgement number then put the acknowledgement number. So here this is the three-way handshake for connection establishment, and this is a three-way handshake for connection establishment. So here you will find out that there are two questions in the gate. I am giving you as a homework question, 2024 ISC Bengaluru question. Based on this picture, based on this picture you can able to answer it. And there is a one more question, 2008 question, that is a homework question. Based on this picture you can also able to solve it. So here is the TCP connection establishment picture, and here I have explained in one way. Two questions are homework question. You have to take that as a first revise this session and then attempt to those question. Definitely you are able to solve it. But remember, tomorrow I'll take a quick recap of this topic and I'll explain this three-way handshaking. So basically what these both are in established state. So I'll revise this topic tomorrow and then do the homework, revise the homework question, and then after that we will move to the four-way handshaking for connection close. So basically in exam sometimes questions are asking on the states: sync, send, establish, listen, sync, receive, establish. So here one transition, one is TCP state transition at the client server side and one TCP transition at the server side, sorry, client side. So both are going to maintain different transition diagram, not same transition diagram. They are not going to use same transition diagram. Client transition diagram is different, server transition diagram is different. I will complete the diagram at the end. So just take a revision. First listen what the three-way, one way, two way, three way. This one way, send, sync, sync, acknowledgement of this sync, this sync, acknowledgement of this sync. So basically what, sync here, sync plus acknowledgement, sync here. So tomorrow I'll make a quick recap of this, then we'll move to the homework question and then connection termination, four-way handshaking. So in GATE two questions are there on connection establishment. So any doubt, better you have to take revision tomorrow. Any doubt then you can ask at that time. Clear? So here I am going to complete the today's session. So today we have started with what? Today we have started with the homework question, and then we have talked about maximum segment lifetime, maximum segment lifetime, and then in which the same topic we have covered wrap around time. Now we are in the topic TCP connection establishment. TCP connection establishment. And it is the three-way handshaking process. It is the three-way handshaking process. So we'll take recap of this and then we'll continue and then we will move to the TCP connection close, and you will get more clarity with the socket programming also. You will get more clarity with the socket programming. So thank you all. Thank you. Jai Hind.